Okay, so we're going to continue from where we stopped, and in this case we're going to look at prime factorization. So we're going to look at what we call prime factorization. Now when you look at this word prime factorization, prime coming from the word prime numbers, and we already defined what a prime number is. In other words, a prime number is a number which has only two factors, that is, the number and 1. So that is what we call a prime number. So what we have to know is that every other number we know can be expressed as a product of its prime numbers. For example, if I have, maybe we can look at example 1. The example 1 is telling us express 12 as a product of its prime factors. Express 12 as a product of its prime factors. So what I'm going to do in this case is, I'm going to divide 12 by its prime factors. So we know that, of course, I start with the very least prime number, and we looked at the set of prime numbers, and we said we start with 2, go to 3, 5, 7, 11, and so on and so forth. So I'm going to look at the very first prime number, whether it divides 12. So in this case I have 12. So I'm going to divide 12 by 2. Is 12 divisible by 2 first of all? The answer is yes. Because when you get 12 divided by 2, you get 6, remainder 0. So meaning that 12 is divisible by 2. So I'm going to have 2. So 12 divided by 2 gives me 6. Then now I look at the 6. Is the 6 divisible by 2? The answer is yes. So I again divide 6 divided by 2, and my answer is going to be 3. I look at 3. Is 3 divisible by 2? The answer is no. Because when you get 3 divided by 2, you're going to get 1, remainder 1. Meaning that 3 does not divide 2. So, after finishing the first prime number, I proceed to the next prime number, which is 3. So, does 3 divide 3? The answer is yes, because 3 divided by 3 is 1. So, I'm going to write 3 here. So, 3 divided by 3 is going to give me 1. So, the moment I reach a 1, I can then stop there. In other words, I have to keep on dividing until I have 1 finally here. Now, after I've gotten this, I come and express these numbers as a product. And we know that product means multiplication. So, on my side here, I'm going to have these numbers here. 2 times 2 times 3. Because we know that when you get 2 times 2, you get 4. 4 times 3 takes you back to 12. So I can express 12 as a product by getting 2 times 2 times 3. Because that is what the question asks. Express 12 as a product of its prime factors. But we know that 2 times 2 is the same as 2 times 2 is the same as 2 squared. Because 2 squared means that I'm going to multiply 2 times. I'm going to multiply 2 by itself 2 times. So 2 times 2 gives me 2 squared times 3. Since 3 is to the power 1, I can write it to the power 1. So this is my answer. I have expressed 12 as a product of its prime factors. And we looked at how you do that. Keep on dividing by the number until you reach a point where that number which you started with can no longer divide this number. You stop there. So we can look at another example too for easy understanding. I can look at a number maybe. Example 2. And in this case I'm required to factorize the following. So my first one can be 90, and my second one could be 75. So I'm going to factorize these two numbers and I'm going to see how it comes about. We say when you're factorizing a number, for example 90, you're going to start by dividing it with the smallest prime number and see whether that smallest prime number divides this number. If it does not, you proceed to the next prime number. If that one also does not, you proceed to the next. So I'm going to have 90 in this case. So I start by 2. Does 2 divide 90? The answer is yes. Because 90 divided by 2, I get 45 remainder 0. So 90 divided by 2, I get 45. Remember we said that you keep on dividing until you have 1 as your last number, just like we had it in the previous example. So I look at my 45. Is 45 divisible by 2? The answer is no, because 45 divided by 2 gives me 22, remainder 1. So I proceed to the next prime number, which is 3. So does 3 divide 45? The answer is yes. Because 45 divided by 3 gives me 15, remainder 0. Meaning 45 divided 3 divides 45. So I can write my 3 here. 45 divided by 3 is going to give me 15. I now proceed. I'm still on 3. I have to keep on dividing by 3 until I reach an extent whereby the number which I have here is no longer divisible by 3. Then I can progress to the next number. So is 15 divisible by 3? The answer is yes, because 15 divided by 3 gives me 5, remainder 1. So I can write my 3 here, and then I get 15 divided by 3. My answer is going to be 5. I'm still continuing because I've not yet got a 1 here. So 5 divided by 3, do I get a remainder? The answer is yes. Because 5 divided by 3 is going to give me 1, remainder 2. So 3 does not divide 5. So I leave 3. I proceed to the next prime number. And we said the first prime number is 2. The next one is 3. The next is 5, 7, 11, and so on and so on. So I've already used 2. I've already used 3. So I proceed to the next one, which is 5. So does 5 divide 5? The answer is yes. Because 5 divided by 5, I'm going to get 1. So in this case, I write my 5 here. So 5 divided by 5 is going to give me 1. And we say that the moment you get the 1 here, then you stop. So what you do after that, you express this number, the 90, as a product of these numbers. So you're going to come down here and say 90 is the same as the product of these numbers. 2 times 3 times 3 times 5. But when you look at these numbers, there is a number that is repeated, and that number is 3. So what do I do after that? When I see a number that is repeated, I can decide to put either a square or a cube, depending on the number of times that number has been repeated. So in this case, since the 2 is only there once, I can write it as 2 power 1 times the 3 is there 2 times, so I can write it as 3 power 2. The 5 is there 1 time, so I can write it as 5 power 1. So this is my final answer. I have expressed 90 as a product of its prime factors. So this is my answer. Last example, we have 75. So I'm going to do the same thing for 75 just like I did for 90 and 12. So if I have my 75 like this, I start with the smallest prime number, which is 2. Does 2 divide 75? The answer is no, because 75 divided by 2 is going to give me 37, remainder 1. In other words, 75 is not divisible by 2. So I proceed to the next prime number, which is 3. Does 3 divide 75? The answer is yes, because 75 divided by 3 is going to give me 25. So I write my 3 here. 75 divided by 3 gives me 25. Then I look at the 25. Is 25 divisible by 3? The answer is no. Because 25 divided by 3, I'm going to get 8, remainder 1. So I proceed to the next prime number, which is 5. Is 25 divisible by 5? The answer is yes, because 25 divide by 5 gives me 5, remainder 1. Meaning 5 divides 25, so I write it there. So 25 divided by 5 is going to give me 5. So I'm still on the 5. Does 5 divide 5? The answer is yes. Because 5 divided by 5, the answer is 1, remainder 0. So I can write my 5 here to show that 5 divided by 5, my answer is going to be 1. And we say that the moment you get 1 as a number here, you stop there and then write the numbers in this column as a product. So in this case, I'm going to have 3 times 5 times 5. But the 5 is there 2 times, so what I do is, I can write it as, the 3 is there 1 time, so I can raise it to power 1. Then the 5 which is there 2 times, I can write it as 5 and raise it to the power 2. So that is my final answer. That is what we call prime factorization. In other words, expressing a number as a product of its prime factors. And remember, we already looked at what prime factors are, and we said these are numbers with only 2 factors. That is 1 and that number itself. So that is how we prime factorize different numbers.